All right. All right. Okay, a couple quick things. Apologies. Canvas, whenever I used to add assignments to Canvas, they defaulted to accepting file uploads. So whenever you see an assignment in Canvas, it would say, read this PDF, open this PDF, answer on a piece of paper, and then upload your paper. I got an email from one of your classmates yesterday, thank you, that said, I don't know where to put the assignments for this week. And I went and looked, and I realized that the default changed. It was no longer an upload, it was no submission, which was so weird to me, because I'm like, why would I give people 10 points for nothing? That seems so odd. So anyway, it's changed now. I think some of you have actually uploaded to it at this point, because I went in and looked, and the checks were grayed out, which means I can't make changes to them, which means somebody put files in. So the quizzes for Friday, tomorrow, if you want to do them, which you don't have to, but if you want to, you can now upload to those spots, and I will grade them on Friday. Hit me now, Drew.
Okay, thanks for waiting. I just emailed it to you.
I think I got yours yesterday. I may have responded to yours. Just stick it in Canvas. And the reason is this. 2 reasons. Not because maybe because I'm a bastard. Take your assignments, put them into Canvas. 2 reasons. First of all, I have no way of grading in my email. I'd have to print out your work, manually grade it, and either scan it and get it back to your bring it to you in class. Secondly, Canvas gives me the option to grade it within Canvas, and you'll have your grade there with any comments I make. Okay. Does that make sense?
Yeah.
So if you do them, just stick your work into Canvas in the area that's now attached to that assignment.
So that's good that you did it.
Yeah, and it's at least one of you did, because I went in just now to look, and the little arrows changed color, which means somebody's putting stuff in the folders now, so that must be what that is. Hit me, Chelsea.
The warm-up from Tuesday, when is that due?
So, warm-up for Tuesday, I apologize. It should have been due in class Tuesday, but I got so excited with the damn birthday problem, chasing that down, that I built a whole quiz off it, and it ate into what we should have had time to do in class. Usually warm-ups, like the one I'm going to hand you first thing today, we'll do in class first thing, and you'll finish it before. So effectively, you can email it to me anytime you want, and it'll become part of the data set. Yeah. Thank you for those of you that did. I appreciate that. And I know that some of the games confused you, which would have been taken care of had we done it in class together. I could have just walked you through it. So, yeah, that was fun though. That birthday problem was fun, and it made a good quiz. If you wanna, anybody try the quiz yet? The birthday quiz? There's a little spreadsheet that's tied to it to talk about, should we have been surprised that we had a birthday match, right? March 24th, that's what it was. Lexi? Kirsten, damn it, where's Lexi? That's Lexi, it was close. And Tegan, and you were March 24th as well, right? You're sitting over here on Monday, that's right. Okay, get there. Kirsten, Tegan, all right. So anyway, if you want to do quizzes this week, by all means do them. I brought an in-class quiz for us to do today too. So that counts as one of the 10 you have to do. So you can choose to do it in class, or you can choose to go take a break for 20 minutes while we do. It's up to you. I'll let you make that decision. Sean, what's up?
Nothing. Yeah.
You just stretch away. I false positive a lot. You can look for, I'm like an amphibian. I see motion. It's also attention deficit. That helps. Okay, so that's that. And I changed all the assignments, including there is a project not due till week 3 on sampling. Has anybody got a chance to look at that yet? Poke into it and kind of, maybe you open it like, ah!
Yeah.
That's fine. That's exactly what I did. Open it. Nope. Not due till week 3. I'm building your second one, which is not due till week 6. I'm also working on your first exam. I like giving you lots of time, not because you need 5 weeks to work on something, but I know how busy you all are. And it might take you 5 weeks to find a couple hours here and there. Trust me. And a kid playing water polo right now and playing drums and all kinds of other stuff. And it's just amazing how much you have to fit stuff in between other stuff. And I know you all are in the same boat. So I try to respect that by giving you enough time to get stuff done. That's why it pissed me off about Canvas not having the upload section. That frustrated me. I was hoping that some of you could have gotten the quizzes done Tuesday and uploaded them right then and been done. But at least you still got them done, most likely. I mean, if you have them done, you have a digital copy. So now it's just a matter of putting it into the mailbox in Canvas. What else? Anybody got any questions? That's all I wanted to tell you as far as like stuff. Any questions, comments, concerns? Looks like most of you came back. Thanks. Hit me, Kirsten.
Okay, on the Fallon quiz, I noticed the percentages added up to more than 100, and I was wondering if that was like a statistics thing or like.
Which percent? On the one in Canvas?
Yeah.
Which percentages?
103 and 101. That's fine.
3 and 101. Can we take a look at that break?
So I got yeah.
Let's take a look at the break, you two, if you don't mind. I wanna take a peek. That sounds, you shouldn't have probabilities over 100%.
Cause I was just adding up the ones on the graph, and, yeah.
Yeah. So remind me again, I'm trying to go back to the, oh!
So it's
I know why. It's a rounding error. Okay, I had to think, so we're doing a Fallon follow-up in the warm-up, we're doing a Fallon quiz in class, and there's the Fallon quiz in class. I had to think about which one it was. It was the one where you had Jimmy Fallon's results compared to the results that I simulated. That's right, I'm remembering now, okay. Yes, I guarantee it's a rounding error, and I think I may have even asked you about that at some point in the quiz, I might not have. It's because there's a very small number of episodes I could watch, and because of that, the decimal that you get when you divide by that very small number becomes unwieldy,
Okay.
and I had to just round off to the nearest number, which ends up being 101% or whatever it ended up being. So that's all. Yeah, it's a rounding error, as it often is when you talk about stuff like that. If I had given you more decimal places, maybe I'll do that next time. Maybe I'll just put like a point something on to bypass that. That's going to happen a lot. But thank you both. Appreciate that. And if anybody else was wondering the same thing, great question. Other questions? Hi. Come on in. We're just talking stuff. That's right, the glittery coffee. Yeah, let's just get into it. Let's do a warm-up. And I'm going to do one first this time, Chelsea, so we don't send you out of here confused as to what the hell you turn this damn thing in. So speaking of Jimmy Fallon, I decided to make the warm-up and the in-class quiz kind of tied back to Jimmy Fallon and Russian egg roulette. Right. And we asked a question. I asked y'all a question last time and wrote down the numbers. I think I have the numbers right there. Put them on the board, I remember. And got it. Yeah. So you're welcome. So think back to yesterday when we were smashing eggs on our heads. Or actually pulling marbles out of bags. We didn't really smash many eggs yesterday. And I asked the question, is it better to go first or second in that game? Or does it matter? So think back to the game. You have a dozen eggs, 4 of them are raw, 8 of them are hard-boiled, and you take turns smashing. And I think I asked you, at some point yesterday, I asked you, is it better to go first or second, or does it not matter? So think back to that game, and then just circle. It doesn't matter what you circle for number one. It's just what you remember from. Sean, go ahead.
The option I want here is I'm pretty sure that you can definitively determine if it does that it does matter in some way, because it's a bunch of discrete probabilities, but I just don't know the answer to that.
Then shoot from the gut right now.
Okay.
And then we'll answer as we go, if that's okay with you.
All right.
And just so you know, you can do it that way. Everything you just said.
Yeah.
So what Sean is saying is, you can figure out mathematically, probabilistically, if it's better to go first or second. However, I want to shut up right now. We're going to come back to however. I want to answer that question further, because it's a great question, Sean.
Okay.
I want to come back and answer it again in a second. Answer 2 while you're at it. Yeah, just answer 1 and 2. Like, pick one and then say, why do you think that? And then stop, because we need data. Oh, maybe that room. Base is omnidirectional, so it's kind of hard to pinpoint where it's coming from. I feel like dogs, unhealthy decisions. What did you put? The class is kind of split. I like
Put
this.
words typically.
What's that?
I usually put words. I don't like to put numbers as my answers.
That's okay. Well, you can't put numbers right now. I mean, you could if we sat down for an hour and a half and drew a very. Who took Math 105? Did I ask you this already? Anybody took Math 105? Deacon, do you remember making tree diagrams in Math 105?
Yes.
Maybe like you would like do things like throw a dart at a balloon. You either hit the balloon or didn't. Then
Yeah.
threw a second dart, and then you either hit the, and then you 2, 4, 8.
Well, it's actually like a whole exam.
Yeah, because those problems take a lot of time. They take a lot of time. So that's how you could attack Sean's point, is you could say, beginning, here, this is not how we're gonna answer this question in this class, because this class changed from a math class to a stats class. Meaning, what you just said, Sean, while 100% correct, is not the focus of Stat 243 anymore. We have taken out quite a bit of the 105-ish probability, which is still a math class, and replaced it with more statistical analysis of data collection, which we're going to get to in a second. But what Sean's talking about, and what Tegan experienced in 105 is true. You can do this as a conditional probability tree. Like at the beginning of the game, there's a bunch of eggs sitting in front of you, yes? A bunch of eggs sitting in front of you. First person grabs an egg and smashes it on their head. What can happen? It's either raw or it's hard boiled, right? It's either going to be raw or it's going to be hard boiled. I mean, that's the only two things that can happen, right? Now the next person goes. Game's not over yet, correct? Game's not over. Second person goes. What can happen to the second person if the first person got a raw egg?
Both things.
Same thing, right? It could be raw or it could be hard boiled. How about if the first person got a hard boiled egg? Same exact thing. And this goes for a while in the same progression, except it's some of the branches will stop eventually in certain places. And we're not going to get into this too much today because this is not the focus of the course. But the third person, I'll just extend it a little bit more. Let's say the third person goes, if the first person got a raw egg and the second person got a raw egg, the third person could again get a raw egg or a hard-boiled egg. If this happens, the game's done. Because now the first person has gotten 2 raw eggs. We should actually call this first, not third, right? Because it's the same person. So that branch then stops, but this branch keeps going. And it gets very, as you remember, Tegan, it gets very cumbersome to keep track of that. So that's how you would answer it discretely, mathematically, probabilistically, Sean. You'd sit down and you'd also have to apply probabilities to each of these branches. We will get into that today in the in-class quiz. I want to get into measuring probability today. Because oh my goodness, you take care of yourself, you hear me? All right. Now, the best way, this class is designed for data collection, analysis, and interpretation, that's why I had you do the 5 games and send me your results, because I want to play with that today. And I got a nice little data set. It's a little data set. It might be easier to kind of deal with than a larger data set. But this one here, what I've done is I've built a simulator. He looks squashed. He looks squashed. That's poor Peyton Manning smashing an egg on his head. So what I've done here, I love Excel. Excel is like one of the greatest tools. Somebody who's taking the 125, Chelsea, oh, wait.
I feared some.
A-L, there's an I, is it? It has what at the end? Hang on. A-L-I, sun. I almost have it. Here, listen. What were you? Now, what did I call on you? You wanted to say something. Tell me what's on your mind.
Excel.
Oh, you're doing Excel. That was the question. Jesus, I got so sidetracked. Remember your name, Allison. It starts with an A. It's got an L and an I. It's got sun. You're my favorite today. All right. So you're taking Excel. You're learning the awesomeness of Excel. Well, Excel can also be used to simulate probabilistic experiments. So what I've done here is I've used random numbers to create eggs. These are them up here. So this represents the draw order of eggs that come out of the carton. I've got 12, even though you don't always need, you're never going to need 12 actually. The most you're ever going to need, we'll get to that in a second. You don't have to worry about that. All you have to worry about is, in this particular game right here, Peyton Manning lost. He went first, and he lost, and you can see why he lost. Here's the order that the eggs came. It's a little bit fuzzy again. I'm sorry about the fuzziness. This is definitely out of focus. But you can see, egg 1 was raw, egg 2 was raw, egg 3 was raw. That means Peyton lost. It went Peyton raw, Magic raw, Peyton raw, game's over, Tom Cruise. Okay? Fair enough? Okay, now, we're gonna play another game. I come over here, I press the F9 button. That time, Magic lost. The eggs re-randomized. I don't know if you can see it up there. The eggs re-randomized. Did you see it? I don't know if you caught that or not. Now the order went raw, raw, hard-boiled, raw. Well, that means Magic got the first 2 raw eggs. Is that fair? Is that cool? So right now it's 50-50. We played 2 games. First guy lost once, second guy lost once. Is that enough data to make a decision?
No.
Doesn't feel like it, does it? It feels like not enough data to make a decision. Then we should play again?
Yeah.
This is much quicker than playing yesterday. Yes, yesterday we were pulling marbles out of bags. You got to keep track of things. Pain in the ass. All right. Poor Peyton. Peyton lost again. Let's see what happened. Hard-boiled, raw, hard-boiled, raw. There you go. So Peyton is the dark, and Magic is the light. Okay. Is that enough data?
No.
No. I can tell you're not amused. So why don't we just let it play for a while? Oh, stay on the damn F9 button there, phone. Nope. I don't even know what the hell just happened. Oh my God! What is going on? Sweet Jesus. You know what? No, don't save it and reopen it again. I should have brought my stapler. My stapler does a much better job of this. There we go. I'm gonna try this again. See what happens. Okay, that worked.
Are the numbers losses?
Yes, this is who's losing. That's why I smashed the raw eggs on their heads.
I gotcha.
See, now we're talking about losses, not wins. Not losses. Y'all let me know when you think we have enough data to make a decision.
Oh
Drew says we have enough data. Sounds like somebody's choking you back down there.
yeah, a little bit.
I think we're good. Should we keep running? Maybe it's an anomaly. We should keep going.
Yeah.
Anomaly? Keep going. Keep going. It's cool. I used to have this set as percentages, but I took the percentages away, and I'll talk about that in a second. What do you think, Allison?
I think we're good.
You think we're? You think we're?
I think
Yeah.
we're good.
You think we're good? You're starting to say, okay, there we go. There's our data set we're going to play with. So, Sean, this is not mathematical proof.
Yes.
By any stretch of the imagination. It's about 1,000, almost 2,000 trials, it looks like. So, I've done 911 trials where Peyton lost. That means the guy that went first loses. And 710 trials where the player that went second loses. So, go ahead and drop those into your warm-up right there. And then see if you can't turn those into probabilities. I know we haven't formally talked about probability yet. That's kind of what the first part of today is talking about them. But see if you can turn those numbers into a probability. And if you can't, don't worry, we'll regroup and we'll chat about it. Tegan, I'm wondering if this ties back to 105 for you at all. I'm curious. It's totally fine if it doesn't.
I took 111 in between these two.
Oh, that erased
But I
everything.
remember a little bit.
That's all good, friend. 111 ruins everything. Still thank you, class, when I said that. She'll kick my ass again.
Do it the other way.
Pre-calc makes everybody sad. No, I'm kidding. Pre-calc is wonderful. Pre-calc is wonderful. It just doesn't help you with Math 243. Or stat. I call it stats. Just like I said, we haven't defined probability. Give it a shot, though. See if you can turn those into probabilities. Then I want to hear you. Kind of combine the answers, and then we'll talk about it.
Like percentage-wise? Is that what you wanted?
I like that.
Okay.
I can think of at least 3 ways, and that's definitely one of them.
Okay.
Yeah. Who's using percentages? Anybody? Using percentages? Cool. Anybody using fractions?
I guess.
Yeah. I bet you the people that use percentages had to use fractions first, didn't you? Anybody using decimals? Decimals get no love. Sorry. see that. Ooh, odds. Oh, how Vegas of you.
I don't know what
I love. Well, this is an open-ended question. We haven't thought about probability formally yet, right? I mean, we kind of hinted at it yesterday when I asked you, is it better to go first or second? But that's hardly measuring a probability. That's just saying, is it advantageous? I mean, now you can answer that question even without using probability, right, Chuck? So you can look at that and go, yeah, don't be Peyton. I mean, it doesn't mean you're gonna win, but it looks like you're gonna lose less. What does that mean? Lose? Ooh, what does that even mean? You're gonna lose less. How many times are you gonna play this game? Think about it. Jimmy Fallon bringing a guest on a show. Tom Cruise going on the Late Show or whatever it's called, the Late Show. What's Jimmy Fallon's show called? Late Night. What is it?
Late night show?
Late Night Show. Sure. How many times is Tom Cruise gonna play Jimmy? Once, right?
Maybe.
They're gonna play one time. Jimmy Fallon Tom Cruise played once. Ryan Gosling played once. Bradley Cooper played once. Anna Kendrick played once. Hers was so awesome. Jodie Foster played once. Michael Phelps played once. It was so cute seeing him get nervous. Dude never gets nervous, and he was like terrified. Manta ray laughed. He was like, bro, look at you. Could eat all of us, all the eggs that Jimmy found. But they all play once. So what does it mean? What does it mean to say, be Magic, don't be Peyton, you'll lose less often, or you'll win more often? What does it mean more often? We'll talk about all that today. All right, give me some numbers. What's the chance or probability, I put it in quotes because we haven't talked about it yet. Chance or probability that the first person loses? Give me some numbers.
56%.
I hear 56%. Let's put some numbers up on the board here. 56%. Bonnie, may I pick your brain a little bit? Where did the number come from?
I just calculated it out, took the total, and then
Total of what, my friend?
the total of games.
Okay. So, how many total games did this simulator play for us?
1,621.
1,621. And you can tell that because 911 of them Peyton lost, and the other 710 Magic lost. There's no other option, right? One of them has to lose. The game is played till one of them loses. Or one of them wins. I guess that's converse, right? So we know we had 1,621 total games. In statistics, maybe you've heard this before. Do you know what that number is called in statistics? It starts with an S. And it ends with ample. That's right. I'm taking a page from the Allison playbook. That's called a sample. And I was asking you earlier, when we played 2, and there was a 1 and a 1, I said, do you have enough trials? They're all like, dude, no. Your claim there was the sample wasn't large enough to see what was going on, right? Then I played another game, and Peyton lost again, and it was 2 to 1. And I said, is that enough? Now what's interesting is, even with just those 3 trials, you already foresaw what was going to happen. But you had no way of knowing that at that point, right? That could have been a weird little anomaly. You ever flipped coin repeated times? I don't know if you've ever done this before. I was making a video last year for 243, and I had to flip a coin 10 times. Now, if I flipped a coin 10 times right now, what do you predict would happen if I did that? Predict what would happen if I flipped a penny or a quarter or a nickel or whatever 10 times. Predict what would happen. Heads and tails. Say that again.
5 heads.
Five heads, 5 tails? Why'd you pick that?
Because it's a 50% chance that you're gonna get it.
That's why we flip coins, right? To decide things. Because you're just as likely to get one side as the other if you flip. Now, okay, my captain. Now, when I did that video for my class, I literally flipped heads 8 times in a row, followed by 2 tails. And I was trying to be a good stat guy and not get excited, but I was so excited. Oh my God, heads again! I'm vibrating.
Isn't there a thing with like heads that's a little heavier than the real?
It is. But here's the thing. Okay. Sit down. Sit down. Okay. On a penny, at least, and probably on other coins too. The head side is heavier than the tail side. As a matter of fact, you know what? That's all I'm going to say. Because I'm going to bring that back in this class. We're going to do the experiment by spinning pennies, not flipping pennies. Because flipping a penny negates any advantage the heads, because you interrupt the spin. You flip it, you grab it, you throw it in your hand. Or you flip it, it hits the ground and bounces around. But spinning it, we can actually tease out that difference. Let's come back, if that's okay, we'll come back to that, like week 6, 7, somewhere in there. I got a fun little experiment plan for that. So it's 50-50, but I flipped 8 heads and 2 tails. If I knew nothing about coins, would that have been a good sample to stop at and be like, well, I guess if you flip a coin, you get heads 80% of the time. I mean, it's ridiculous, right? So the best thing to do is to do a lot of trials until you begin to see the pattern suss out. This is the problem with overly small samples. They might be representative of the overriding population. We'll come back to that phrase probably on Tuesday next week. But they probably aren't. They're probably a little bit skewed in one way or the other. Another word we'll come back to next week. All right, Bonnie, keep going. 1,621, where'd this come from?
That came from dividing, I did first player loses.
Yep.
Their total first.
Let's go first player, I like that better.
Yep.
Ugh. Yep, first player loses, go ahead.
And I just divided 911 by 1621.
I love that. So that's why I asked if who used fraction, if you use percentages. Chances are if you use percentages, you also had to get a fraction to get that percentage, didn't you? Yeah. And that is where Bonnie got your 56%, yes? So I'm gonna predict that your second player losing is whatever's left.
Yeah.
44%, I'm guessing, yeah. So second player loses 44% of the time. Which is which magic has there. Let's check something real quick. I'm gonna come back and get more answers. Let's run some more trials. How y'all doing? You doing okay? I'm just collecting more data while we're hanging out talking. The part that blows my mind about this is, I couldn't do this 10 years ago. Excel didn't have the capability of iterative calculations, which is this isn't what Excel is supposed to do. You're not supposed to make Excel. Ask Lou, is Lou your teacher for 125? Cousin Al?
I'm gonna be completely honest, I don't know.
That's okay. Does he go, do, a lot?
No,
He doesn't.
it's
It's not
online, so.
Oh,
I have no
maybe he
idea.
doesn't do that online. I wish he would, because it's awesome.
He has a beard, that's all I know, and he has a cute dog that he has a picture with. I could probably get a picture of him.
Please do. I want to know who it is now. That's not fun. Okay. Bonnie, could you, actually everybody, recalculate Bonnie's percentage real quick. What is the percentage the first person loses now?
That's 6, 59.
That's 56%? What'd you get?
I mean, I got 55.9.
56%.
56%, yeah? Probably not exactly the same as we had before, but you see how it's hovering right around that same percentage of 56%? What do you think would happen if I ran a few thousand more trials? If you look at the relative size of the bars, I wish I had taken a screen grab of the first one and then compared it to this one. Relatively, they're about the same size, aren't they? That's a measure of percentage. The bars continue to grow. As I hold down that F9 button, the bars continue to grow, but they're growing in a proportional way, as the one is growing about 12% faster than the other, which is the difference between the 56 and the 44. And this is the importance of making sure your sample is large enough to be able to tease out that difference. Now, what is large enough? We'll get into that later in the course too. There's no one right answer for that, unfortunately. This is one of the things people hate about stats. Like, you can't say like, do 100, do 200, do 300. The quick and easy answer is more data is always better, so long as it's good data. And what's good data? And we're going to get into that in the first project. So anyway, I'll cycle back to that in a second.
You can always have more data, you can't have small data, right? Or like you can always.
Believe it or that's a fantastic question, Allison. I have done statistical analyses on as small samples as 3 and 6 data points, because that's all I had access to. My cousin is a physical therapist. She had this little tiny cohort of people that finished an experiment with her. 3 data points, that's all she had. She's like, what can I do? I'm like, well, you can do a lot with it, you just have to make allowances for the fact that it's so small. Another data set was, oh my God, this is gonna go way back. The one that comes to mind, do you remember the BP Deepwater Horizon explosion in the Gulf of Mexico? This is going back a ways now. Yeah, when the BP, a big oil derrick off the coast of the Gulf of Mexico exploded and started leaching oil into the Gulf of Mexico. tens of thousands of gallons of oil into the Gulf of Mexico over the course of like a month. Everybody was estimating how much oil was leaking out of the pipe, and the numbers were all over the place. So what I did was I partnered with a scientist down in Louisiana, and I found out online that he was goofing around. I'm like, how are you getting these numbers? And actually, this is probably 15 years ago now, he set up a camera, or they had a camera down near the leak, and he was able to find particles on the camera image that were going by the video image of the oil coming out, and he knew the size of those particles, so he could tell how fast those particles were moving. And from that, he could figure out how fast the oil was moving. And because he knew the diameter of the pipe, and then he's like, this is where my math sucks. I'm like, well, this is where my math is good. And then we partnered together, and we actually figured out, before the feds knew how much oil there was, we figured out how much oil there was. 6 data points, that's all it took. So, again, Allison, fantastic question, not an easy answer, not a quick answer. Does that make sense? Love that question. Yeah. If you can get more data, more quality data is always better than less quality data. More garbage data is always useless. I mean, I'm a drummer and I love recording. And one of my favorite things I ever saw in a recording studio was a bronze plaque hanging on the wall, looked like an Emmy, and it said, "You can't polish a turd." And I remember looking at that, staring at it for a couple seconds. I'm like, I get it. I get the joke. And my buddy David often says, he's a guitar player, singer. He's like, it's a microphone, not a miracle. And I love that too, you know? So it's what comes out is only as good as what you put into it. And that's data. You know, if you've got a little bit of good data, you're still gonna get a better response or a better result than a whole lot of bad data. Great question. Long answer for a very good question. Okay, good. Who got something similar? 56%, 44%?
Yeah.
Got something similar to that? That's cool. Chelsea, I love what you did. You did odds.
Okay.
You did, well, I lost the numbers now, but I think it was like 9/11 to 7/10. Anybody do it that way? 9/11 to 7/10? That's cool. That is a statistical construct called odds. That's what Vegas talks about.
Okay.
Vegas talks about odds, betting on games and betting on card games. Like, you ever heard 2 to 1 against? Something like that. 2 to 1 odds against. You ever heard? If you have heard that, fine. If you haven't, I'm never going to talk about it again. No disrespect, Chelsea. No disrespect. But odds just are their own animal, and they're kind of in their own category.
Okay.
Very useful. Very useful, just not kind of where the focus of this course is. Odds are just another way of talking about probability. Let's talk about 2 to 1 odds. 2 to 1 odds. No, even better. Imagine a 6-sided die in your mind. Imagine a 6-sided die. Okay, Sean, pick one of the numbers on a 6-sided die.
We'll go with 4.
We'll go with 4. Okay, grab that die and roll it. Let's create a game real quick. You pay $5. If you roll a 4, you'll win back 25. If you don't, you lose your $5. Let's just make up the game real quick. Okay, so if you pay $5, roll the die. If you roll a 4, I'll hand you $25. If you don't, you'll lose your $5 that you bet. Okay, don't worry about whether you play that game or not. What are the odds against you winning? It's 5 to 1, and this is where odds get confusing. The probability seems like it should be 6 to 1, right, Drew? Mm-hmm. Right? Odds are defined as unsuccessful to successful. So there are 5 ways to lose and 1 way to win, so it's 5 to 1. Probability, there's 1 way to win out of 6 total things of happening. That's probability. That's what Bonnie did, right? That's probability. Number of ways to win over total number. So for a die, rolling a 6-sided die and betting on 4, the chance that you're going to be winning is 1 out of 6. 1 successful outcome out of 6 total outcomes. Chance of losing is 5 to 6. 5 unsuccessful to 6 total. Odds ignores the 6 and just talks about the 5 and the 1. Vegas loves to do this for some reason. And I find it very confusing because the first thing I have to do is figure out what those 2 things add up to and then convert it to a percentage because I can't think in terms of odds. Like 2 to 1 odds, okay, that's 2/3 to 1/3. That's the first thing my brain has. And we're going to focus on probabilities in here when we use them. Is that fair, Chelsea?
Thanks for explaining.
Oh, absolutely. You're going to see it. Some of you already have. You'll totally see odds in your life. If you ever go to Vegas and see all those numbers up on the board, they're all odds. So, okay, cool. Now, what do they mean? What does 56% mean? And I don't want you using the word probability. I want you to explain this to somebody who isn't gonna be taking a stats class. So don't use the word chance, because chance is too statty. Don't use the word probability. Can you describe the 56% to me without using like fancy math phrases?
I'll take a shot. It's very clinical.
Hit me!
Okay, I put in 56% of observed trials, the first person to pick an egg lost, while in 44% of trials, the second person to pick an egg lost the game.
You say clinical, I say perfectly understandable. Who agrees? Tell me your name again.
Andrew.
Andrew! Do we like that? Oh my God, that's literally what we saw. Well, maybe not anymore because I changed it. But hey, that's the year Oregon became a state. Where's the 65?
I think it's 65.
Damn it!
But I could be wrong. Let's look it
No, I'm not looking up. I changed it to 65. It's not when it's there.
up. Oh,
Yeah, I feel better now. If it was 57, you're so pissed at you shows. Say it again, Andrew.
Oh, my entire sentence?
Yeah, please.
Okay, in 56% of observed trials, the first person to pick an egg lost, while in 44% of trials, the second person to pick an egg lost the game.
God, that is like a perfectly stated, no jargon explanation of what we saw, right? We did an experiment, we're reporting back. We didn't use the word probability. We didn't use the word chance. We just said, we watched it a bunch of times. 56% of the time this happened, the other 44% of the time this happened. Bonnie, hit me with something else.
With another explanation?
Yeah. Was that what you were gonna say? I saw your hand pop up, I was curious.
No,
Or did you just like Andrew's?
I mean, I was agreeing, but I did have different phrasing.
Go ahead.
I wrote, you are slightly more likely to lose going first than if you go second.
That's perfect. The only thing, it doesn't explain the 56%. It explains the difference between the two, right? It explains the difference between the 56 and the 44. There's about what is it, a 12% difference, yes? That's measurable. That's a measurable difference. That's a better difference than, anybody ever heard of counting cards in blackjack? That's a way better advantage than counting cards. If you could somehow monetize this, somehow. Drew, what you got?
Doesn't counting cards only give you like a small percent?
It's like a
chance?
half of a
And
percent.
that's if you play like a shit ton of hands.
And that's how you make money. You have to play a shit ton of hands and not get caught doing it. Because they will keep you out of the casino. They won't beat you up like in that movie. It's not that way. But they will ask you to leave because it's private property. But yes, you have to, basically you can, I tried to actually make a project out of counting cards, like an Excel simulation project. But it's a nightmare. It's a nightmare. But what I've come away with, Drew, is yes, you have to play basically thousands and thousands of hands and not get caught to make a minor profit. Which is why the kids from that movie 21 were brilliant. They didn't play one person at a time, they played a whole team of people simultaneously and they capitalized on the advantages. Wonderful book and a wonderful movie.
That movie's good, yeah.
It's so good. The book is, I remember reading the book years and years ago and then they made the movie, which was even better, so. Okay, so far I heard in 56% of trials, person going first loses, while the other 44, this person going second loses. Bonnie says that gives us a statistical advantage of going second. You should go second, you should place yourself second, which is what the quiz that I believe Kirsten was asking about for Canvas explores that a little bit, and where Jimmy chooses to place himself when he plays. Who else has got something? Or you have something similar? Allison, hit me. You're just moving. See, I see motion. What do you got, G-Man?
Based on the observed data, the first person is more likely to lose by 12%.
Oh, I love that too. Oh, that's good. So that's a combination of both. All three of you are kind of feeding off each other with these answers. I like that. The big thing, I love the 56% of trials. And we could even, if you want to, yours is the most correct way to say it. Yours is going to be more correct than what I'm about to say, Andrew. 56% of the time, the first player loses. 44% of the time, the second player loses. Now, that's not as correct as what Andrew said, because you said of the observed trials, which is literally what this is based on. It's based on the trials we ran. But you noticed also that when we ran more trials, it stayed 56%. It deviated by, what, 1/10%, I think, up and down? Now that deviation around, I'm gonna hit you some terms right now, and then we'll come back to them on Tuesday. These numbers are called statistics. The 56% is a statistic. You've heard that phrase before. Well, hell, you're sitting in a class called Intro to Statistics, right? You're sitting here. What is a statistic? Anybody have any idea what it is? At this point? No, Sean, that's why I'm sitting here. I have to learn what the hell it is. It's just a measure of a sample. You've done a sample, and you're trying to figure it out. Now, Sean, you alluded to something else earlier when you said I bet you we can sit down and figure out mathematically what the chances are of winning first and second. You can. That's called a parameter. Am I done already? It's okay. It's okay. That's called a parameter. We'll come back to these terms on Monday, I promise. Or Tuesday. A parameter is a measure in the entire population that you're interested in. So in this case, if you're interested in the population of everybody playing Russian egg roulette, which nobody really is interested in, but if you were, you could, according to what Sean said, which is true, you could actually calculate it. But in statistics, this is kind of a weird, fun way of starting the study of statistics by looking at a fun little example. What's something you'd actually be interested in your chosen field? The percentage of what? What would you be interested in? Something that you might care enough about to research. What do you think, Johnson? Yeah, hit me.
Which jobs make the most money? And
Oh my
CFS
goodness.
careers?
Oh, I love that. So I've got a career path. I want to figure out which job. That's interesting, actually. That's interesting. Because with enough coffee and time, you probably actually could scour the entire job market all over the world and get the true average value of a job in a certain field.
I think I'd wanna just stick to board for looking something.
Well, that would take less coffee and less time.
Okay.
But it could still be done. I was thinking something a little bit more like ethereal, like only because I have it and our son has it. What percentage of American males are ADHD? That's interesting for a couple different reasons. First, we have to define firmly what ADHD is, because the kind I have and the kind he has are very similar but very different. And the kind my buddy Damien has, who I play music with, is totally different than both of ours. So we have to kind of figure out what is the checkbox for ADD, right? And then, assuming that we can get a good definition, how do we then find them all? You have to measure every single person. Is that going to happen?
No.
Why is that not going to happen?
Too many people.
It's too many,
You can't.
right? And while we're sitting here talking, I hate to say this, but one of those people just died.
Yeah, you
They
can't
did,
say
right?
what-
Somebody just got old and died. And hell, while we're talking here, what else just happened?
Someone was born.
Somebody was just born and they might have ADD, we gotta test them too. So it becomes impossible to actually measure entire population. So what do you draw?
The same.
Echo. You draw an echo. Did I mention I have ADD? You draw a sample. Now, and we're gonna come back to this on Tuesday again. The sample is gonna be a little bit off, most likely, from the true population, because you didn't count everything. So we have to learn how to deal with that. And that, honestly, is probably the largest part of this class, is how do you deal with that uncertainty? But dealing with that uncertainty starts with dealing with how you measure certainty, which is probability. Chelsea, ask me that question, because you got a question I can tell.
I can't hide things.
No, you can't. I can play poker with you any day, because I know exactly what you're thinking.
That's why I don't go to Vegas. That's why I was thinking, this is not like where the standard deviation comes in.
Oh, how dare you.
Oh, good, okay.
Oh, how dare
I was
you.
really
That
worried.
is so much one of our favorite measures in this class, which we're not meeting that today. That's a little much for the first week, but yes. Yeah, how do you measure how off your result is? Oh, bless you, bless you. Promise we get to that. Promise. This class rules. Totally rules. Where do we pick, who's heard that phrase, standard deviation, before? Yeah, a couple of you. Where did you hear it before? Can I ask? AP Stat, that's right, a couple of you did take AP Stat, that's right. Lexi Allison did take AP Stat, I forgot about that. Kirsten, where have you heard it?
I had like a pre-stats class junior year, so,
Nice. Where was that?
Beaverton.
Oh, you said in high school you had a pre-stats
Yeah,
class.
yeah.
That's so cool that it's starting to dribble down into high school now, finally, 25 years of teaching. My teaching career is older than Google. Google just turned 25 like this week. And I remember when it came out, I'm like, what's this? Like, that's awesome. Sean, hit me.
Yeah, I believe in my pre-calc class, we did a quick, like, we had a couple extra weeks we were ahead. And
What's
so
in the
we
back of
did-
the book? Hey, stats!
Yeah, so
I
we
know
did some
literally.
stats stuff.
I know exactly. Where'd you go to high school?
Summit.
Summit, okay, yeah, Mountain View does the same thing. I go over there sometimes and I was like, what do you do in like May? They're like, we do probability. I'm like, it's a pre-calc course. Like, yeah, it's in the back of the book. And I'm like, these poor children, these poor kids. Let them take a stats class later. Anyway, so it sounds like we got it from a bunch of different places, which is great. But yes, that's a measure we'll get into probably at the end of next week, beginning of week 3. It's one of my favorite measures because it's intuitive but counterintuitive all at the same time. So thank you, Chelsea, for that. Appreciate it. So what have we learned from this warm-up? Can we measure probabilities?
Yes.
Can I get a hell yeah? Can I get a hell yeah?
Hell
yeah.
yeah.
Thank you, G-Man. Good Lord. It's not that early anymore. We can measure probabilities if we have the correct numbers that to form their ratio. And what are those probabilities? What does that 56% mean? That 44%, or whatever the probability? Let's flip a coin. Somebody said it earlier. The chance of getting heads is, Allison, you told me, 50%. What does 50% mean? And you can't say there's two sides of a coin and one's heads. So what are you gonna tell me?
I don't know.
I don't know what I'm gonna say now, because nothing else I'm gonna say. So there's a 50% chance of flipping heads, yes?
Mhm.
Explain to me what that means without referring to the number of sides on the coin.
You have an equal chance of hitting heads as you do tails.
I love that. Explain it using the word 50%, G-Man. I love what you just said. Use the word 50% in your answer.
Percent?
Yeah, I want you to use the word 50%. I want you to use the number in the answer, but don't refer to the fact that 50% of the sides are heads. I know, it's hard, isn't it, Drew?
You can't say like 5 out of 10.
You say since the
I accept that, because you said 5 out of 10 times. Can we just substitute 5 out of 10 with 50%? 50% of the time, you're gonna get heads. If you keep flipping a coin, half the time, you're gonna get heads. Do you have to know how many heads and tails it has to understand that statement?
No.
You just mean that you should